So this is an assignment or a handout that we're going to be going over in class. I know some of you are going to be missing, and so I wanted to kind of create a quick video going through parts of this assignment. I don't know that I'll get through every question on it, but I'll do my best to get through a good majority of this and kind of show you a little bit about what we're going to be doing in class with this assignment. So the idea here is that we are looking at the construction of a pool that may or may not have some kind of deck built alongside or around it. And we're going to be writing quadratic functions to represent the area of the pool, which we're going to call P of x. That's the function going to be called P of x. The area of the deck, which is a function that's going to be called D of x. And then the total area of the pool and deck combined, which we're going to call A of x, or area, or all together. I guess that could be what the A is standing for. And again, we're going to be representing these as quadratic functions based on the variable x, where x might be, in some of these examples, a dimension of the pool, or x might be, in some examples, a dimension of some part of the deck. So just to remind ourselves for a second, when it says write a quadratic function, we know that quadratic functions are functions that have a squared variable term and sometimes a variable term that's to the first power and sometimes a constant term, which is meaning it doesn't have a variable attached to it. So like the standard form of quadratic functions are ax squared plus bx plus c. And so we're going to be writing our functions kind of in standard form for each of these pools and the various functions that we're going to write for the pools and decks combined. Okay, so pool number one that you can see here is just this pool where there's no deck built around it, and its dimensions are just x by x. I don't know what units we're using here, whether it's feet or yards or meters or whatever, but this pool is an x by x pool, so it might be a little pool that's like 10 feet by 10 feet, might be a big pool that's like 40 feet by 40 feet. The question is, if I don't know what the actual measurements of x are, what function would represent the area of the pool? And I guess to do this, we need to remind ourselves that the area of a rectangle, so area of a rectangle, is found by taking, some people say length times width, or some people say base times height. In other words, we're just going to multiply two sides together to find the area of any rectangle. And since squares are technically rectangles, this formula also works for squares as well. So in this example where we have a square pool, our pool's area is just going to be found by taking x times x and getting us x squared. And that's about as simple as this one's going to get. We're going to move on now, though. We're going to be looking at some more complicated pool and deck designs. So we'll go to pool number 2 here, which you can see it's the basic pool that we had in pool number 1, but then we've added this deck alongside it, and the deck goes all the way along one side of the pool, and it goes 3 units out from the pool. So this area right here is our deck area, and this would be our pool area. So first of all, I'm going to be trying to consistently do these in like 3 different colors. So I'll do the pool area in this kind of yellow color. We know that's still going to be x times x, which is still going to give us x squared. But then the deck, which I'll do in this like kind of lime or this minty green color, so that's going to be the area of this part right here. Let me just outline the pool in yellow color. So that's our P of x. How about our D of x, or our deck area? Well, this is a rectangle with one side as 3, and then it has this other side right here, which would be x, right? It's going to be x on this side and x on this side. So the area of that deck would just be 3 times x, which is 3x. And then the area of the altogether, like the entire shape altogether, let's think about what that area is going to be. We'll do that in this kind of orange color. That's the area of this entire thing. There's 2 ways that we can think about this. We could look at this as one big rectangle and think about the side lengths, which would be x on this side And then this side here would be x for this part plus 3 for this part. So it would be x plus 3. And then we could find the area of this rectangle by doing one side times the other side. So we could take x times x plus 3, and then we could use the distributive property and do x times x to get x squared and x times 3 to get 3x. So our altogether area could be looked at as x squared plus 3x. Another way we could have gotten that, you might notice, is if we had just taken the area of the yellow part, which is x squared, plus the area of the green part, which is 3x, and just said x squared plus 3x. And so that might be a good way of doing some of these other ones. But either way, we would get x squared plus 3x for the area of the pool and the deck combined together. So based on what your dimensions of the pool are, you'd have a different altogether area. A bigger pool would give you a bigger area altogether for this deck. Or sorry, this deck and pool combined. So that's pool number 2. Pool number 3 is going to look pretty similar to that, only you can see that we've added on this extra part to the deck down here, this 2 unit by 2 unit part down here. But let's still go through and find P of x, D of x, and A of x. So our pool area, it's the same pool as we've had for the first two. So that still has an area of x squared. But our deck area now, our deck area is this rectangle combined with this rectangle or square right there. So now that's the deck that we're finding the area of. We know that this part is still going to be 3x. This part right here would be an area of 2 times 2, which is 4. So our deck area altogether would be taking the 3x part plus the 4 part. So our deck area would be 3x plus 4. Now our altogether area, again, that's this whole shape right here. We're finding the area of this entire shape. We could, I think, the best way to do this would be to take the pool area plus the deck area. So the pool area is going to be x squared. We're going to do that plus 3x plus 4. So if we write all that out just as one function, it would say x squared plus 3x plus 4. And that's our altogether function. Our a of x function is x squared plus 3x plus 4. So now let's move back up to pool number 4. Scroll back up. So pool number 4 looks a little bit different now. You can see what we have for pool number 4 is we have this pool here kind of in the corner, and then we've built a deck kind of on two sides of the pool. And on this side of the pool, the deck goes out 5 units. On this side of the pool, it goes out 3 units. And then we kind of complete a rectangle, basically, so that the pool and the deck combined makes this big rectangle right here. So how about our pool area? Well, that is still going to be x times x, which is x squared. But our deck area, I think, is going to be a little bit more complicated to find. And the best way I can describe to you to find this deck area, and it's going to work for pool 5 and pool 6 as well, because we don't have a formula to find the area of a shape that's like this. There's no set formula to find the area of this L-shaped deck. So what I'm going to do is I'm going to break that deck into 3 different rectangles, because I know I can find the area of a rectangle fairly easily by doing this length times width. So I've broken this deck into 3 different rectangles, and as long as I know the dimensions, the length and width of each of these rectangles, I can find the area of each one and then combine them all together to find the deck area function. So let's look at this rectangle right here. I can see that it's 5 units on this side, and then this side and this side, I guess it's 5 units on this side as well. These other 2 sides would be x, right? Because if this is a square, I'd have an x there and an x there. So this side would be x and that side would be x. So the area of that rectangle is just going to be 5 times x, which we would write as 5x. This rectangle right here is going to be 3 times x, right? It's got one side that's 3 and one side that's x. So that area would be 3x. This rectangle, we can see it has this side, which is 5, and then this side would be 3, the same as this segment over here. So this rectangle would have an area of 3 times 5, which is 15. So all together, the three rectangles together would be 5x plus 3x plus 15. I just added these three areas together, and that's going to give me 8x plus 15 for the deck area. There are other ways we could have found that. We could have looked at the length of this side of this big rectangle and the length of this side of this big rectangle and tried multiplying those two parts together and then taking out the x squared. It's a little more complicated. I think doing it this way is probably our best bet. But now finding the altogether area, we know we're going to take the pool area plus the deck area. And so that's going to be equal to the pool area of x squared plus the deck area, which said 8x plus 15. So all together, our a of x function would say x squared plus 8x plus 15. So there we can see a quadratic function that represents the area of the pool combined with the deck. Again, the bigger your pool, as we increase this x value, we would expect that this total area is going to keep getting bigger as well. In pool 5, that would be the next one that we're going to take a look at. In pool 5, you can see we have a defined pool size. It's 3 units by 4 units, whatever units we're using. So our pool has a defined size, but then around the pool, we're building this deck, which we haven't decided how wide that deck is going to be. It's going around it, kind of like a frame around a picture, right? So our pool area is pretty straightforward. It's just 3 times 4, which is 12. So that's going to be our pool area. But the deck area is going to be, I think, a little bit more complicated. Because again, I don't have a formula to find the area of this picture frame type shape that's going around the pool. So again, what I'm going to do is I'm going to divide it up into a bunch of simpler shapes. And for this one, what I'm going to do is I'm going to divide it up into these 4 squares that are like at the corner, and they're all x by x. And then I would have 4 rectangles, one here, you can see one here, and then again down here, and then again over here. So I got my 4 squares and I got my 4 rectangles. If I find the area of each one of those shapes and combine all that together, that would be my deck area function. Well, each of these is an x squared because it's an x by x square. So that's an x squared, and that's an x squared, and that's an x squared, and this is an x squared. So I know that my deck area is going to have all 4 of these x squareds added together. But then it's also going to have these 4 rectangles. Now let's look at the area of each of these rectangles. This rectangle right here is a rectangle with one side of 4 and then one side of x. So that would have an area of 4x. This one down here is identical to it, so it also has 4x for its area. So I'm going to add these two 4x's together. And then here and here, I have a rectangle that's 3 by x. So it has an area of 3x. Again, 3 by x, so 3x. So I'll add, I'm running out of space over here, so I'm going to come down here, add two 3x's. Now if I combine like terms in this big, long function, I can see I have 1, 2, 3, 4x squared terms, so that's 4x squareds, plus 4x plus 4x is 8x, plus 3x is 11x, plus another 3x is 14x. So the deck area is 4x squareds plus 14x. Now my altogether area, I'm going to do it the same way I did on the last couple. I'm going to take my deck area and my pool area and combine them together. And that's going to say equals 12. Let me write that in yellow, sorry. Try and be consistent here. 12 plus 4x squared plus 14x. So that's going to say 12 plus 4x squared plus 14x, but we want to write this in standard form where we have the x squared term out at the beginning. So I'm going to say 4x squared, then the 14x next, and then the 12. So our altogether area is 4x squared plus 14x plus 12. Now I'm going to leave pool 6 for you. I think this video has gone on long enough for about a 15-minute mark. So you could use the same idea that we used for pool 5 to figure out the three functions for pool 6, the pool area, the deck area, and the altogether area. Again, it's going to look a lot similar to what we did up here. The difference being we know that the deck is going to be 3 feet wide going all the way around it. The pool this time, we don't know how long it's going to be. One side is going to be x and one side is going to be twice as long, or 2x. So give your best shot to finding these 3 functions there, and we'll talk about probably a little bit more the next time you guys come to class.